Welcome to the Crazy Hat Chemist. So here's another video on thermochemistry. Bam! So standard heat of formation calculation number 1. We're going to determine the standard heat of formation for the combustion of methane, that's CH4, using a table of standard heats of formations. And that is an appendix in the back of your textbook. So the first thing that we need to do is we need to actually write out the equation for the combustion of methane and then balance it. So the combustion of methane is CH4 plus, what is the other necessary reactant for any combustion reaction? Oxygen gas, and that is O2 because it's diatomic. The products will always be what for a complete combustion? That is right, carbon dioxide and water vapor. And then you need to balance that equation. And this is what you should get for your balanced equation for methane. Okay? So hopefully that works out well for you. All right, now, this is the next part that we need to know, and that is the delta H naught is equal to the sum of, that's the sigma, delta H naught of formation of the products minus the sum of the delta H naught of formation of the reactants. Okay, so this is how I remember this equation. Your parents' favorite radio station is maybe a yes or maybe a no on this one, and it is called NPR, National Public Radio. So this is read as delta H naught. There's the N for NPR in naught. That's that little circle that's highlighted in yellow, okay? And then P for the products and R for the reactant. So it's NPR. If you love the radio station or if you hate the radio station, but you can certainly use that to get this equation here, because this equation is essential to solving this problem. You're going to look in the back of your textbook and you're going to find the standard heats of formation. Okay, they are standard because they're at 25 degrees Celsius in 1 atmosphere. We already talked about that previously. These are in kilojoules per mole, and you should see all these values on there. Just so happens that oxygen is not found in the index of my, the appendix of my textbook. And I'm like, wait, oxygen is not found. And here's why it's not found. Because elements in their standard state are not found in your textbook in the appendix because those values are 0. So any element in its standard state is 0 for a standard heat of formation. That makes it very simple. So now what you're going to do is you're going to refer back to this slide here and you're going to use these values right here, okay, to substitute into this products minus reactants, and you're going to get the standard heat of formation for methane for this equation. Okay, now I have included a partial table here for you, and I've included some things that are useful and some things that are not useful, just so that you understand that when you look at that table in the appendix, there's going to be a plethora of different formulas and compounds here for you to look at. You need to pick the correct formula, okay, and its state of matter. Because right here I have water that's a liquid and water that's a gas. Which water am I going to use? I'm going to be using the water that's a liquid because that's what's in my equation. I also have hydrogen peroxide on this one, and that's also to screw you up and mess you up as well. There is no hydrogen peroxide in there. So that might be one of the questions is, well, I'm giving you a partial table, but I'm including things that are not essential. And many people find that, well, elements in their standard state are not in the table. Well, the reason is because those values are 0. Okay, so you're going to know those values right there, and then we're going to move on to the next slide and then plug into the delta H naught, sum of products minus sum of reactants for standard heats of formation. Okay, so we're going to reference the table on the previous slide here, and it is products minus reactants. Hopefully you know what the products are, you know what the reactants are. The products are carbon dioxide and water. The reactants are the methane, that's the CH4, and the oxygen. Okay, so I've included that all in here. So it's products minus reactants. So you should see the delta H naught for the reaction is equal to 1 mole of carbon dioxide, that's the stoichiometric coefficient, and then times the delta H naught of formation for the carbon dioxide, plus 2 moles for the water times its delta H naught of formation, and that's in kilojoules per mole. You should see that the moles are going to cancel out here. I'm going to have kilojoules. Then there's a minus sign in between the products and the reactants, and then it's 1 mole of methane and its standard heat of formation, plus 2 moles of oxygen and its standard heat of formation. So let's plug in some numbers in here. And I've plugged in some numbers here. I don't have the kilojoules per mole. I apologize for that. Otherwise, the numbers became really tiny on my slide here. So each of the numbers from the table had kilojoules per mole, but I did pay attention to make sure I picked out the correct numbers. Notice that there's a 0 for the oxygen gas. That's very important, okay? And then we plug in these numbers here, and I got rid of the units here and the formulas just so that the numbers are larger so that you can see them here. I did pay attention to that negative sign between the products and the reactants as highlighted in yellow. This is a simple algebraic problem here. You're going to do a little bit of multiplication, a little addition here, and your addition is going to have one decimal place, essentially. So there's the delta H naught for this reaction. That is negative 890.2 kilojoules. Okay, and that is for the combustion of methane. Notice that this is a negative value. That should tell you that this is an exothermic reaction, as all combustion reactions should be as well. Hopefully that makes sense. That means combustion reactions, there's heat liberated from them. That's why that's a negative value. All right. Hopefully you enjoyed that. Here's another crazy hat for you. Well, it's the 50th anniversary of Disneyland. And give me a thumbs up for that video. Subscribe to my YouTube channel. And I'm going to see you for another awesome video on standard heats of formation. See you next time. Bye now.